Another topic is all about frames and its reactions. We have here an example problem. Determine the reactions at the support for the frame. As you can see in the diagram, it is supported with a roller and a hinge. We must determine its determinacy. It is internally stable since it doesn't have any hinge or roller connected within the structure. So the reaction is 3, member 2, joins 3, easy 0. Solving it, 3m plus r, 3g plus ec. 3 times 2 plus 3, 3 times 3 plus 0. So the answer will be 9 is equal to 9, which is statically determinate externally. Since we determine the determinacy of the frame, we must proceed to solving for the reaction of supports, wherein summation of horizontal forces is equal to 0. 2 plus 3 over 2 times 26 times 5 over 13 plus c of x equal to 0. c of x equal to negative 25k. c of x equals 25 kips. Solving for the reaction of the force to get the cy. Summation of moment at A equals to 0. Negative 20 times 13 minus the area of the triangle, 1/2 times 1 times 26 times 26 over 3 minus 50 times 24 plus 12 plus 25 times 10 plus cy times 48 is equal to 0. So the answer will be cy is equal to 48.72 kips. Then after that, we will determine the force AY. So, summation of vertical forces is equal to 0. AY minus 2 plus 3 over 2 times 26 times 12 over 13 minus 50 plus 48.72 is equal to 0. So, our AY will be 61.28 kips. Our next topic will be cables and arcs and its reactions. So first, what is cables? Cables are flexible structure in pure tension. They are used in different engineering applications such as bridges and offshore platforms. General cable theorem. The general cable theorem states that at any point on a cable that is supported at two ends and subjected to vertical transverse loads, the product of the horizontal component of the cable tension and the vertical distance from that point to the cable cord equals the moment which would occur at the section if the load carried by the cable were having an assembly supported beam on the same span as that of the cable. So we have here an example problem. A cable supports two concentrated loads at B and C as shown in figure. Determine the support reactions, sag at B, the tension in the cable, and the length of the cable. This is a cable that is supported with two hinges. There are 4 reactions. First, we will solve for support reactions. At moment of A is equal to 0, we will get the force dy. Negative 100 times 2 minus 80 times 10 plus 13 dy is equal to 0. So the answer will be dy is equal to 76.92 kilonewton. Then, the summation of all vertical forces is equal to 0 to get the force AY. AY plus 76.92 minus 100 minus 80 is equal to 0. So force AY will be 103.08 kilonewton. Summation of all the moment at C is equal to 0. To get the force AX, negative AX times 10 plus 100 times 8 is equal to 0. So AX is equal to 80 kilonewton. Summation of all the horizontal forces is equal to 0. Negative dx plus 80 is equal to 0. Force dx is equal to 80 kilonewton. Since we have solved all the support reactions, we must now solve the tension at A and D. Tension A is equal to tension AB is equal to square root of AY squared plus AX squared is equal to square root of, substituting the value of AY, 103.08 33.08 squared plus substituting the value of AX is equal to 80 squared. The answer will be tension A is equal to tension AB is equal to 130.48 kilonewton. Then tension D is equal to tension DC is equal to square root of dy squared plus dx squared. Substituting its values is equal to square root of 76.92 squared plus 80 squared. So we will get the answer. Tension D is equal to TDC is equal to 110.98 kilonewton. For now, we will solve for the sag at T. So, summation of moment at B is equal to 0. Negative AY times 2 plus AFX times YB is equal to 0. YB is equal to AY times over AX is equal to 103.08 times 2 over 80. The answer will be 2.58 meters. Now we are going to solve for the tension in segment CV. We have to find all the horizontal forces by summing it up. Summation of f of x is equal to 0. Then tension CD, cosine of 73.3 degrees is equal minus tension at CV, cosine of 42.8 degrees is equal to 0. Now we're going to divide it. Tension of CD, cosine of 70.3 degrees over cosine of 42.8 degrees. Since we have the equation, we will now substitute the value of tension at CD is equal to 110.98 cosine of 73.3 degrees over cosine of 42.8 degrees. This will have that the tension CB is equal to 43.46 kilonewton. So now we have to solve for the length of cable by using Pythagorean theorem. Square root of 2.58 squared plus 2 squared plus square root of 10 minus 2.58 squared plus 8 squared plus square root of 10 squared plus 3 squared. By this, we can get the length of the cable 24.62 meters. Arches. Arches are structures composed of curvilinear members resting on supports. They are 2-hinge arc, 3-hinge arc, and fixed arc. So we have here an example problem. A parabolic arc with support at the same level is subjected to combined loading. Determine the support reactions and the normal thrust and radial shear at the point just to the left of the 150 kilonewton concentrated load. This is a 3-hinge arc. Considering the whole structure, we are solving for the reaction of supports. At moment A is equal to 0, by times 40 minus 150 times 8 minus 4 times 20 times 30 is equal to 0. So, By is equal to 90 kilonewton. So, summation of all vertical forces is equal to 0. Force AY plus 90 minus 150 minus 4 times 20 is equal to 0. So, force AY is equal to 140 kilonewton. Solving for the reaction of supports, arc segment AC. So, at moment C is equal to 0, force of AX times 12 minus 140 times 20 plus 150 times 12 is equal to 0. Force of AX is equal to 83.33 kilonewton. Again, considering the inter-arc, summation of all horizontal forces is equal to 0. 83.33 minus force of BX is equal to 0. So B of X is equal to 83.33 kilonewton. Another topic is all about deflection in beams. There are many ways in order to analyze a beam. Using double integration method. This method entails obtaining the deflection of a beam by integrating the differential equation of the elastic curve of a beam twice and using boundary conditions to determine the constants of integration. The first integration yields the slope and the second integration gives the deflection. Using area moment method, this method, the area of the bending moment diagrams, is utilized for computing the slope and or deflections at particular points along the axis of the beam or frame. Using conjugate beam method, the conjugate beam method takes advantage of the similarity of the relationship among load, shear force, and bending moment, as well as among curvature, slope, and deflection.